Laki or Lakagígar is a volcanic fissure in the south of Iceland, not far from the canyon of Eldgjá and the small village of Kirkjubæjarklaustur. Lakagígar is the correct name, as Laki mountain itself did not erupt, as fissures opened up on each side of it. Lakagígar is part of a volcanic system centered on the Grímsvötn paragraph Tn volcano and including the erupt volcano. It lies between the glaciers of Mýrdalsjökull paragraph and Vatnajökull paragraph, in an area of fissures that run in a southwest to northeast direction. The system erupted over an 8-month period between 1783 and 1784 from the Laki fissure and the adjoining Grímsvötn paragraph Tn volcano, pouring out an estimated 14 kilometers 3 of basalt lava and clouds of poisonous hydrofluoric acid and sulfur dioxide compounds that killed over 50% of Iceland's livestock population, leading to a famine which then killed approximately 25% of the island's human population. The Laki eruption and its aftermath caused a drop in global temperatures, as sulfur dioxide was spewed into the northern hemisphere. This caused crop failures in Europe and may have caused droughts in India. The eruption has been estimated to have killed over 6 million people globally, making it the deadliest in historical times. 1783 eruption. On June 8, 1783, a fissure with 130 craters opened with photomagmatic explosions because of the groundwater interacting with the rising basalt magma. Over a few days the eruptions became less explosive, strombolian, and later Hawaiian in character, with high rates of lava fusion. This event is rated as 6 on the Volcanic Explosivity Index, but the 8-month emission of sulfuric aerosols resulted in one of the most important climatic and socially repercussive events of the last millennium. The eruption, also known as the Skaftarelda or Welder, produced an estimated 14 kilometers 3 of basalt lava, and the total volume of tufa emitted was 0.91 kilometers 3. Lava fountains were estimated to have reached heights of 800 to 1,400 m. The gases were carried by the convective eruption column to altitudes of about 15 kilometers. The eruption continued until February 7, 1784, but most of the lava was ejected in the first 5 months. Grímsvötn paragraph Tn volcano, from which the Laki fissure extends, was also erupting at the time, from 1783 until 1785. The outpouring of gases, including an estimated 8 million tons of hydrogen fluoride and an estimated 120 million tons of sulfur dioxide, gave rise to what has since become known as the Laki haze across Europe. Consequences in Iceland. The consequences for Iceland, known as the Mýrdalsjökull were catastrophic. An estimated 25% of the population died in the famine and fluoride poisoning after the fissure eruptions ensued. Around 80% of sheep, 50% of cattle and 50% of horses died because of dental fluorosis and skeletal fluorosis from the 8 million tons of hydrogen fluoride that were released. The parish priest and dean of Vesta Skaftafelsa 1/2 Slak, Jakub Densteingra MSSON, grew famous because of the old messa that he delivered on July 20, 1783. The people of the small settlement of Kirkjubæjarklaustur were worshipping while the village was endangered by a lava stream, which ceased to flow not far from town, with the townsfolk still in church. This past week, and the 2 prior to it, more poison fell from the sky than words can describe: ash, volcanic hairs, rain full of sulfur and saltpeter, all of it mixed with sand. The snouts, nostrils, and feet of livestock grazing or walking on the grass turned bright yellow and raw. All water went tepid and light blue in color and gravel slides turned gray. All the earth's plants burned, withered and turned gray, one after another, as the fire increased and neared the settlements. Consequences in monsoon regions. There is evidence that the Laki eruption weakened African and Indian monsoon circulations, leading to between 1 and 3 mm less daily precipitation than normal over the Sahel of Africa, resulting in, among other effects, low flow in the River Nile. The resulting famine that afflicted Egypt in 1784 cost it roughly 1/6 of its population. The eruption was also found to have affected the southern Arabian Peninsula and India. Consequences in Europe equals, an estimated 120 million long tons of sulfur dioxide was emitted, about 3 times the total annual European industrial outputs in 2006, and equivalent to 6 times the total 1991 Mount Pinatubo eruption. This outpouring of sulfur dioxide during unusual weather conditions caused a thick haze to spread across Western Europe, resulting in many thousands of deaths throughout 1783 and the winter of 1784. The summer of 1783 was the hottest on record, and a rare high-pressure zone over Iceland caused the winds to blow to the southeast. The poisonous cloud drifted to Bergen and Denmark, Norway, then spread to Prague and the Kingdom of Bohemia by June 17, Berlin by June 18, Paris by June 20, Le Havre by June 22, and Great Britain by June 23. The fog was so thick that boats stayed in port, unable to navigate, and the sun was described as blood-colored. Inhaling sulfur dioxide gas causes victims to choke as their internal soft tissue swells. The gas reacts with the moisture in lungs and produces sulfurous acid. The local death rate in Chartres was up by 5% during August and September, with more than 40 dead. In Great Britain, the records show that the additional deaths were among outdoor workers. The death rate in Bedfordshire, Lincolnshire and the East Coast was perhaps 2 or 3 times the normal rate. It has been estimated that 23,000 British people died from the poisoning. The weather became very hot, causing severe thunderstorms with large hailstones that were reported to have killed cattle, until the haze dissipated in the autumn. The winter of 1783-1784 was very severe. The naturalist Gilbert White in Selborne, Hampshire, reported 28 days of continuous frost. The extreme winter is estimated to have caused 8,000 additional deaths in the UK. During the spring thaw, Germany and Central Europe reported severe flood damage. The meteorological impact of Laki continued, contributing significantly to several years of extreme weather in Europe. In France, the sequence of extreme weather events included a surplus harvest in 1785 that caused poverty for rural workers, as well as droughts, bad winters and summers, and a violent hailstorm in 1788 that destroyed crops. These events contributed significantly to an increase in poverty and famine that may have contributed to the French Revolution in 1789. Laki was only one factor in a decade of climatic disruption, as GRA-MSVA paragraph TN was erupting from 1783 to 1785, and there may have been an unusually strong El Niño ±0 effect from 1789 to 1793. Consequences in North America In North America, the winter of 1784 was the longest and one of the coldest on record. It was the longest period of below zero temperatures in New England, with the largest accumulation of snow in New Jersey, and the longest freezing over of the Chesapeake Bay, where Annapolis, Maryland, then the capital of the United States, is located. The weather delayed congressmen in coming to Annapolis to vote for the Treaty of Paris, which would end the American Revolutionary War. A huge snowstorm hit the South, the Mississippi River froze at New Orleans and there was ice in the Gulf of Mexico. Contemporary reports Gilbert White recorded his perceptions of the event at Selborne, Hampshire, England. The summer of the year 1783 was an amazing and portentous one, and full of horrible phenomena. For besides the alarming meteors and tremendous thunderstorms that affrighted and distressed the different counties of this kingdom, the peculiar haze, or smoky fog, that prevailed for many weeks in this island, and in every part of Europe, and even beyond its limits, was a most extraordinary appearance, unlike anything known within the memory of man. By my journal I find that I had noticed this strange occurrence from June 23 to July 20 inclusive, during which period the wind varied to every quarter without making any alteration in the air. The sun, at noon, looked as blank as a clouded moon, and shed a rust-colored ferruginous light on the ground, and floors of rooms. But was particularly lurid and blood-colored at rising and setting. All the time the heat was so intense that butcher's meat could hardly be eaten on the day after it was killed. And the flies swarmed so in the lanes and hedges that they rendered the horses half frantic, and riding irksome. The country people began to look, with a superstitious awe, at the red, lowering aspect of the sun. Benjamin Franklin recorded his observations in a 1784 lecture, during several of the summer months of the year 1783, when the effect of the sun's rays to heat the earth in these northern regions should have been greater. There existed a constant fog over all Europe, and a great part of North America. This fog was of a permanent nature. It was dry, and the rays of the sun seemed to have little effect towards dissipating it, as they easily do a moist fog, arising from water. They were indeed rendered so faint in passing through it, that when collected in the focus of a burning glass they would scarce kindle brown paper. Of course, their summer effect in heating the earth was exceedingly diminished. Hence the surface was early frozen. Hence the first snows remained on it unmelted, and received continual additions. Hence the air was more chilled, and the winds more severely cold. Hence perhaps the winter of 1783-4 was more severe than any that had happened for many years. The cause of this universal fog is not yet ascertained. Or whether it was the vast quantity of smoke, long continuing, to issue during the summer from Hekla in Iceland, and that other volcano which arose out of the sea near that island, which smoke might be spread by various winds, over the northern part of the world, is yet uncertain. To the east and the Grímsvötn paragraph TN volcano was erupting about 75 miles northeast. Additionally Katla, only 31 miles southeast, was still renowned after its spectacular eruption 28 years earlier in 1755. Sir John Cullum of Bury St Edmunds, Suffolk, England, recorded his observations on June 23, 1783, in a letter to Sir Joseph Banks, then President of the Royal Society. About 60 unregistered trademark clock. Good morning, I observed the air very much condensed in my chamber window. And, upon getting up, was informed by a tenant that finding himself cold in bed, about 30 unregistered trademark clock in the morning, he looked out at his window, and to his great surprise saw the ground covered with a white frost, and I was assured that 2 men at Barton, about 3 miles off, saw in some shallow tubs, ice of the thickness of a crown piece unregistered trademark. Sir John goes on to describe the effect of this frost unregistered trademark on trees and crops. The aristae of the barley, which was coming into ear, became brown and withered at their extremities, as did the leaves of the oats. The rye had the appearance of being mildewed. So that the farmers were alarmed, for those crops the larch, Weymouth pine, and hardy Scotch fir, had the tips of their leaves withered unregistered trademark. Sir John unregistered trademark's vegetable garden did not escape. He noted that the plants looked exactly as if a fire had been lighted near them, that had shriveled and discolored their leaves unregistered trademark. See also. References. Further reading, Brechet, M. and Grattan, J. Environmental and Social Responses in Europe to the 1783 eruption of the Laki fissure volcano in Iceland, a consideration of contemporary documentary evidence in Firth, C. and Maguire, W. J. Volcanoes in the Quaternary. Geological Society, London, Special Publication 161, 173 187, 1999, Chris Castledine. Iceland, Modern Processes and Past Environments. Elsevier. ISBN 978-0-444-50652-8. Grattan, J., Brechet, M. and Sadler, J. Modeling the Distal Impacts of Past Volcanic Gas Emissions, Evidence of Europe-wide Environmental Impacts from Gases Emitted During the Eruption of Italian and Icelandic Volcanoes in 1783 in Quaternary, 9, 25 €35. 1998. Grattan, D., Scher 1/4 Tenhelm, R. and Brechet, M. Volcanic Gases, Environmental Crises and Social Response in Grattan, J. and Torrance, on Natural Disasters and Cultural Change, Routledge, London 87 €106. 2002. Grattan, J. P. and Brechet, M. B. An Amazing and Portentous Summer, Environmental and Social Responses in Britain to the 1783 eruption of an Iceland volcano in the Geographical Journal 161, 2, 125 euro 134. 1995. Richard B. Stothers. The Great Dry Fog of 1,783 inches in Climatic Change, 32, 79 euro 89, 1996. The Summer of Acid Rain, Economist, December 19, 2007. Thorvaldur Þórðarson and Stephen Self. Atmospheric and Environmental Effects of the 1783 euro 1784 Laki Eruption. A Review and Reassessment in J. Geophys. Res. 108, D1, 4011, doi, 10.1029/2001 JD002042, 2003. Whites, Alexandra and Jeff Kenipe. Island on Fire, The Extraordinary Story of Laki, the volcano that turned 18th century Europe dark. Profile Books, 2014. ISBN 9781781250044. External links, photos and information about the volcanism at Laki, Lakagígar, A Meditation on January Cubed Enstaingra MSSON from Anglicans Online Drive John Grattan at International Volcanic Heath Hazard Network, A Sulfurous Stench, Illness and Death in Europe following the eruption of the Laki fissure, The Dry Fog of 1783, Environmental Impact and Human Reaction to the Lakagígar Eruption.